Welcome to Spring LIB.
So for this problem, we're told that we have a photon with a wavelength of 520 nanometers, and we're asked to find the frequency of that photon, the magnitude of its momentum, and its energy. So this is going to be a pretty direct application of equations we should have relating to photons. So to start with the frequency, we know that for any wave, the velocity of that wave is going to be equal to the wavelength times the frequency. So a photon is a wave here, so no exception. And we have then that the speed of light is just equal to the wavelength times the frequency for that photon. So we can just solve for frequency, and so that will be speed of light divided by lambda, and then we just plug in those values. So speed of light, 3 times 10 to the 8th meters per second, and our wavelength of 520 nanometers, so that's times 10 to the minus 9th meters. And so we evaluate that, and we should get a frequency of 5.77 times 10 to the 14th hertz. So there's our frequency. Now for the magnitude of momentum, this is again something we just have a direct equation for. So momentum for a photon is just Planck's constant over the wavelength. So we can again directly solve for this. So Planck's constant, 6.626 times 10 to the minus 36, and that is joule seconds. And then divided by the wavelength, so 520, and again times 10 to the minus 9th for nanometers. So we evaluate this, and we should get 1.28 times 10 to the minus 27 momentum units, so that's kilograms meter per second. So there is our momentum. And finally, we want the energy here. So energy of a photon is just Planck's constant times the frequency of that photon. So again, 6.626 times 10 to the minus 36 joule seconds. And we've found the frequency in that first part. So that was just 5.77 times 10 to the 14th hertz. And so when we evaluate that, we should get an energy of 3.84 times 10 to the minus 19th joules. And finally, they asked us to convert this energy into electron volts. So we'll just come up here to do that. So 3.84 times 10 to the minus 19th joules. So we just want to either remember or maybe more realistically look up our conversion factor for electron volts. And so when you do that, you find that it is in 1 electron volt, there are 1.602 times 10 to the minus 19th joules. So this ratio is just 1, so we can just multiply it by what our energy was. So these joule units cancel out, so we'll only be left with electron volts up top. And so now we just evaluate this. So 3.84 times 10 to the minus 19th over 1.602 times 10 to the minus 19th, and we should then get 2.4. And so that'll be electron volts. And so there we go.